Welcome to today's teaching. In today's lesson, we'll be looking at indices. So indices is in this form. We have a raised to the power n. A here is the base, while n here is the power or index. Power or index. And today we'll be looking at laws of indices. Laws of indices. Laws of indices. The first law is when you have this form, a raised to the power n multiplied by a raised to the power n is the same thing as a raised to the power n plus n. Multiplication will change to plus. For example, when we have a raised to the power 5 multiplied by a raised to the power 3 is the same thing as a raised to the power 5 plus 3, which will give us a raised to the power 8. Then the second law is when we have this form, that same a raised to the power n divided by a raised to the power n. When we have it in division form, that division sign becomes minus a raised to the power n minus n. For example, when we have a raised to the power 5 divided by a raised to the power 3 is equal to a raised to the power 5 minus 3, and that will give us a raised to the power 2. Then the next form or the next rule is when we have a raised to the power m into bracket raised to the power n. This form is a raised to the power n, that is n multiplied by n. For example, a raised to the power 6 into bracket 5 raised to the power 5 is the same thing as a raised to the power 6 times 5, and that will give us a raised to the power 30. Then the next law, 4, when we have a raised to the power 0 is equal to 1. Then the next form, when we have a number 5, when we have the square root of a is equal to a raised to the power 1 over 2. Now we are looking at fractional indices here. As we have square root, we also have cube root. Cube root of a is written as a raised to the power 1 over 3. Then we also have fourth root of a. Fourth root of a is given as a raised to the power 1 over 4. Then we have fifth root in that order, like that. And this one also can also be written as, for example, we can also have this one in this form, this one as n, so that this is equal to a raised to the power 1 over n, like that. Now from here we can apply all these rules, all these laws in solving indices. Then we can also have indical equations. We also have indical equations. That is equations in indices. You can call it a simple exponential. Indical equations. What do I mean? For example, when we have 5 raised to the power x equal to 125, and you have to solve for x. Remember that you are solving in indices. The interpretation of this is 5 raised to the power x, which is equal to, you break this one down, write it in the base of 5, because you are working in base 5. This is index, this is the base. That means we are going to have 5 times 5, which is 25. 25 times 5, 125. That is 3 times. That is 125 is the same thing as 5 times 5 times 5, which is equal to 5 raised to the power 3. Therefore, 5 raised to power x is equal to 5 raised to power 3. Now, what are we going to do here to get our final answer, to get x? Since the base, we have equal base, you equate the power. You equate the power. So base will go, equate the power. And what is the power? That means that x is equal to 3. X is equal to 3. Then we can also have it also in this form. Example, this example 1 here. Let's take this one to be example 2. Under this, example 2, when we have 8 raised to power x, which is equal to 0.125. That means we can also have it in this form. So you have to look for x, for example. To find x here, that means that you are going to have 8 raised to power, that will be 125 over, you move your 0 3 times, 1, 2, 3. So that means 1,125 will give us 0.125. That is the interpretation. That is the interpretation. Therefore, we are going to have 8 raised to power s is equal to, now, when you look at this, that means we're having 8 raised to power, that is 1 over 8. The interpretation of this is 8 raised to power x, which is equal to 8 raised to power minus 1. Okay, this is another rule in indices. Another rule in indices, when we have 1 over 8 is the same thing as what? 8 raised to power minus 1. 8 raised to power minus 1. Therefore, we have the same base. We just equate what? The power. We have the same base. Our x is equal to minus 1.